Reflection of sound. In this module, we will learn about reflection of sound and its uses, echo, reverberation. Reflection of sound follows the same laws as the reflection of light. Let us do one activity. Take two long identical tubes and place them near a wall. Ask your friend to speak softly into one of the tubes. Use the other tube to listen. Adjust the tube till you hear the best sound. You will hear your friend's voice best when the tubes make equal angle with the normal to the wall. This is because of reflection of sound, which states that the angle of incidence and the angle of reflection from equal angles to a normal on the reflecting surface. If the tube carrying the incident sound and the tube carrying the reflected sound is not in the same plane, then no sound can be heard. If you repeat the same experiment with different materials, you will observe that hard surfaces reflect sound better than soft ones. Unlike light, which is reflected from highly polished surfaces, sound reflects quite well from rough surfaces. If you shout or clap standing at a suitable distance from a reflecting object, such as a tall building or a mountain, you will hear the same sound a little later. This reflected sound is called echo. Echo is a repetition of sound produced by reflection of sound waves from a reflecting surface. The sensation of sound persists in our brain for about 0.1 second and is called persistence of sound. To hear a distinct echo, the time interval between the original sound and the reflected sound must be at least 0.1 second. This means that if the sound is reflected in less than 0.1 second, then echo would not be heard. For the sound to reflect after 0.1 second, there should be a minimum distance of approximately 17.2 meters between the source and the reflecting surface. Let us derive a formula to calculate speed of sound if we hear an echo. Let the distance traveled by the sound from source to the obstacle be d. Then, the distance traveled by sound from obstacle to the source is d. Thus, the total distance traveled by sound would be 2d. Let echo time be t seconds. We know that speed is equal to total distance traveled upon echo time. Calculate the speed of sound if an echo is heard after 0.8 seconds, when a boy fires a cracker 132 meters away from a tall building. Given echo time is equal to 0.8 seconds. The total distance traveled by sound wave is 2d is equal to 2 into 132 equal to 264 meters. Speed of sound v is equal to 2d upon t equal to 264 upon 0.8 equal to 330 meters per second. Reverberation is perceived when the reflected sound wave reaches the ear in less than 0.1 second after the original sound wave. Since the original and the reflected sound wave tend to combine, we get to hear one prolonged sound wave. In an auditorium or a big hall where reverberation is undesirable, the roof and the walls are generally covered by sound-absorbent materials like fiberboard or rough plaster. The seat materials are also selected on the basis of their sound-absorbing properties. Reverberation is quite different from an echo. A reflected sound arriving at the position of the listener more than 0.1 second after the direct sound is called an echo. A reflection of sound arriving at the listener in less than 0.1 second after the direct sound is called reverberation. The principle of multiple reflections of sound has several applications. Megaphones, horns, musical instruments such as trumpets, and loudspeakers are designed to send sound in a particular direction without spreading in all directions. In these instruments, a tube followed by a conical opening reflects sound successively to guide most of the sound waves in the forward direction. Stethoscope is a medical instrument used for listening to sounds produced in the body, mainly in the heart or lungs. In this instrument, the sound of the patient's heartbeat reaches the doctor's ears by multiple reflection and amplification. Generally, the ceilings of the concert halls, conference halls, and cinema halls are designed such that the sound after reflection reaches all corners of the hall. In some halls, a curved ceiling is arranged in such a way that the sound after reflecting from the ceiling spreads evenly across the hall. Human ears can hear sounds of frequencies ranging about 20 Hz to 20,000 Hz. We cannot hear sounds of frequency below 20 Hz and above 20 kHz. However, the limits vary from person to person and with age. Children can hear sounds of frequency up to 30 kHz. For elders, the upper limit falls to 10 to 12 kHz. However, 20 Hz to 20 kHz is taken as audible range of average person. Even in audible range, the human ear is not equally sensitive to all frequencies. It is the most sensitive to frequencies of about 2000 Hz to 3000 Hz, where it can hear even a very low intensity sound. Sound of frequency less than 20 Hz is known as infrasonic sound or infrasound. Sound of frequency more than 20 kHz is known as ultrasonic sound or ultrasound.